Hello and welcome to Saurabh Sir's classes again. We move to the next question in the quant section. This question says, for any positive integer n, let fn be equal to n into n plus 1 if n is even and fn is equal to n plus 3 if n is odd. If m is a positive integer such that 8 of fm plus 1 minus fm equal to 2, then find the value of m. Now, we know that any even number minus another even number will be an even number, or an odd number minus another odd number will be an even number. Now we see that 2 is even and 8 into fm plus 1 will always be even because 8 is even. So fm has to be even. Now we see that if there can be two cases, m is odd. If m is odd, then fm will be equal to m plus 3. So since m is odd, this is odd, so odd plus odd will be even. So fm becomes even if m is odd, and if m is even, then fm will follow this formula, that is m into m plus 1. Now since m is even, so fm will be even. So again fm becomes even. So whether m is odd or even, fm will always be even. So therefore we cannot specify whether m is odd or even to start with. So let us take the first case as m is odd. So if m is odd, then fm will follow the odd rule, that is m plus 3, and if m is odd, then m plus 1 will be even. So f of m plus 1 will follow the even rule. So it will take this value, will be equal to, we put m plus 1 in place of n, so m plus 1 into m plus 2. So therefore 8 into f of m plus 1 minus fm is equal to 2 will become 8 into m plus 1 into m plus 2 minus m plus 3 is equal to 2, or 8 into m square plus 3m plus 2 minus m plus 3 is equal to 2. So this becomes 8m square plus 8 into 3 24m minus 1m, which is plus 23m, and we have 8 into 2 16 minus 3 13 minus 2 11 plus 11 is equal to 0. Now you see that we have the constant term as 11 and the coefficient of m square as 8 and the coefficient of m as 23. So you cannot break 23 in any way to give 88. So therefore you cannot factorize this quadratic equation to give integral values of m. M cannot be an integer if you solve this equation. So therefore the assumption of m being odd is incorrect. So hence m has to be even. Now if m is even, then let's work it out. So now we know that m is even, so therefore fm will follow the even rule, which is this one, is equal to m into m plus 1, and m plus 1 will be odd, so if m plus 1 will follow the odd rule, which is this one, which is equal to m plus 4, and we have 8 if m plus 1 minus if m is equal to 2, or 8 into m plus 4 minus m into m plus 1 is equal to 2, or we get 8m minus 1m, which is 7 plus 7m, and 8 into 4 32 minus 2, which is equal to plus 30, and we get minus m into m, which is minus m square, is equal to 0, or we can write this as m square minus 7m minus 30 is equal to 0, and this can be factorized into m minus 10 into m plus 3 is equal to 0. So therefore the value of m can be plus 10 or minus 3, but it is given that m is a positive integer, so therefore the value of m will be 10. So 10 is the correct answer. We move to the next question, which says, in a class 60% of the students are girls and the rest are boys. So we have girls and boys. So girls are 60%, therefore boys are 40%. There are 30 more girls than boys. So the difference between girls and boys is 30 students. So 60% minus 40% of the total number of students, which is S, is equal to 30. Therefore the total number of students, which is S, is equal to 30 by 20%, or 30 by 0.2, which is equal to 150. Now out of this 150, we know 60% are girls, therefore girls are 90 and 40% are boys, so boys are 60. If 68% of the students, including 30 boys, pass an examination, what is the percentage of girls who do not pass the examination? So it is told that 68% of the students means 68% of 150, which is equal to 102. This many students pass the examination, and out of which 30 were boys. So 30 were boys, and 72, which is 102 minus 30 is 72, are girls. So 72 girls passed the examination. So passed the examination 72 girls out of 90. So therefore 18 girls did not pass, and what they are asking, the percentage of girls who did not pass. So percentage of girls who did not pass is equal to 18 divided by the total number of girls 90 into 100, which is equal to 20%. So 20% is the answer to this question. We move to the next question, which says if a1 plus a2 plus a3 all the way up to an is equal to 3 into 2 to the power n plus 1 minus 2 for every n greater than equal to 1, then what is the value of a11? Now we can do this kind of problem in two ways. Either we can substitute the values of n to find the values of a1, a2, a3 and so on, or we can first find out the generic value of the term an from the given equation and then substitute values of n to find the corresponding values. So it is given that a1 plus a2 plus a3 plus a n minus 1 plus an is equal to 3 into 2 to the power n plus 1 minus 2. So therefore the sum of these terms a1 plus a2 up to an minus 1 will be a1 plus a2 plus all the way up to an minus 1 will be equal to 3 into 2 to the power n minus 1 plus 1 minus 2, which is 3 into 2 to the power n minus 2. So if I subtract this series from this series, then we will get the value of an, because n is the term which is not there in the second series. So we will subtract the second series from the first one. So this is S1, this is S2. So S1 minus S2 will be equal to an will be equal to 3 into 2 to the power n plus 1 minus 2 minus 3 into 2 to the power n minus 2, which is equal to 3 into 2 to the power n plus 1 minus 2 to the power n minus 2 plus 2. So this one cancels out. So this becomes 3 into, I can take 2 to the power n out as a common factor, into 2 to the power n into 2 to the power 1 minus 1, which is 2 minus 1 is 1. So this becomes 3 into 2 to the power n. So a n is equal to 2 to the power 3 into 2 to the power n. So therefore a to the a11 will be equal to 3 into 2 to the power 11. So which is nothing but 3 into 2048, which is equal to 6144. This is the answer to this question.